Hello, my dear student. Welcome to Exam Prep Tool. If you are preparing for GATE CSE or GATE DA, this is the correct place. 300 questions, 300 quality questions I am going to explain here. Mostly in GATE examinations, questions will come from these 300 questions only. Most of my students every year used to say this only to me. Sir, questions came from your notes. So I'm strongly saying to you, don't miss one question also out of these 300. It will really helpful to you in the examination. You will get a lot of advantage. First of all, myself, I am Subbarao Lingam Gunta. My students used to call me Reddy sir. I have 14 years of teaching experience. I guided more than 25 lakh students. Right? And one more thing I want to say to you, I am from IIT Bombay, right? In computer science department. I am the GATE top ranker. All my team members are IITians. 300 quality questions we made. Don't miss one also. Definitely most of the things will come in the GATE examination. And while seeing this lecture at anywhere, if you find out any doubt, this is our WhatsApp number, right? Message us. This is our WhatsApp number. Please message us, right? Your doubt will be resolved by our team members. Hope this class will be really useful to you. Go ahead. Thank you everyone. Yeah, what is the answer of this? Read the problem. Today I am going to cover, I think 20 problems I am going to cover. I am going to cover 20 problems, right? Please concentrate, right? So in this 20, I am very sure 20 problems I am going to cover. In this 20, I am very sure one question guarantee will come. The 20 questions which I am going to say, pakka one question will come. I am very confirm in this, right? So I am starting now. So it is the first problem. In the last class maybe we done. Yeah, that's okay. Let us assume that it is once again. Consider there are two hosts X and Y with IP address. Two IP addresses are given. And two subnet masks also given. So with respect to subnet mask and IP, which are belongs to same network. Which are belongs to same network. That is the thing what he is asking. So I think we done this problem. What you have to do? See this one. X and SMX do. Y and SMX do. In the similar way. Y and SMY do. X and SMY do. Whichever matching, that is the answer. Yeah, we already done this. This is the way. Just to do end operation. End operation of this you do. End operation of this also you do. Right? End operation of this also do. End operation of this also do. Right? You will get the answer. Suppose assume. With the SMX, I done X also, I done Y also. Suppose assume that these two are given A. Means with respect to SMX, X and Y belongs to same network. Suppose these two are given B. Means with respect to SMY, X and Y belongs to same network. Just to do end operation. Right? So I'm doing once again. See this one. X SMX, Y SMX. Do end. It is A. Assume both are right with respect to SMX. Both are same network. X SMY, Y SMY. Do end operation. Assume that both are B. So with respect to SMY, both are on the same network. Just to do end operation. Yeah, what is the answer for this? What about this one? 0. What about this one? 0. Just do end operation. I am not done anything. End operation do. End operation do. SMX. SMY. One, see the options properly. See the options properly. So I got to know answer is SMX is satisfying, SMY is not satisfying. See what is the problem? What is the problem? Host X and Y belong to different network with respect to subnet mask Y, true. Host X and Y belongs to same network with respect to subnet mask X. So answer is both 1 and true. So he played some game with the options. Please verify. This is true. With respect to Y, they are different. With respect to X, they are same, true. 3. Someone is saying, no sir, why it is in different network? Yeah, can you see this? Can you see this one? 10, 128, 0. 69, 128, 0. Come to the Y. 10, 192, 0. 69, 192, 64. So he played with options some game. See here, I think this bit is matching. 64. Right, both the statements are true. X and Y belongs to different network with respect to subnet mask Y, true. X and Y belongs to same network with respect to X, true. So answer is 3. Everyone, so these kind of questions will come in the exam, please take care. These kind of questions will come in the exam, please take care. This is the question number 1. What is the question number 2? Yeah, question number 2. Similar, can you do once again? Similar, can you do once again? Consider 3 machines M, N and P with IP addresses, something is given. So I think three machines, IP address is given. With respect to subnet mask this. What about these 3 machines? Do end operation. I think subnet mask, if you observe, right? These are anyhow once only. Right? See, one and anything is anything. One and anything is anything. That is the reason these people no need to bother. Just concentrate. 252. So I am targeting, I think last octet only required. 252. This is M. Next one, 5252. This is N. Next one, 252. This is P. Can you do end operation properly? 252. 252 means last 2 people. Last 2 people are not ones, remaining all. 10 means last 2 people. So it is 0. 152. So 5 means 101. 252 means 100. I think 1. So 4 will match. 6 and 252. 6 can be written 110. 252 is going to be, right? All ones are there, right? It is going to be 0, 0. I think 1, 4. So N and P same network. N and P belongs to same network, B. Last 2 bits matters. Please see in every number. Last 2 bits. N and P belongs to same subnet. Yeah, question number 2 also done. For 12 subjects of GATE examination, every subject is approximately 200 questions to 300 questions. 300 quality questions were designed. 12 subjects, every subject 200 to 300 quality questions were designed. Approximately 2400 questions to 3600 questions. 3 right, these many quality questions were designed with video solutions. Mostly in GATE examination, all questions will come from these only. 12 subjects, every subject 200 to 300 questions. Our team is all IIT experts. Myself, as I mentioned to you, 14 years. Most of my students are there in IIT. Most of my students are there in MNCs, big MNCs. Most of my students are top 100 rankers, top 10 rankers, top 50 rankers. If you solve all these questions, I'm very sure, I'm very sure your rank will improve by at least 10 times. Through experience, I'm saying mostly questions will come from these questions only. Don't miss at any cost. So for if you want to subscribe for this course name is called as rank improvement course. Rank improvement course for CS, rank improvement course for DA. For admissions, you can WhatsApp me to this particular number, or you can directly go to exampreptool.com. Exampreptool.com. You can subscribe from there also. It is really useful to you. Don't miss at any cost. This is utilize the last 2 months quality time in the quality way. I hope you will get a lot of benefit from this. All the best. Can you go to question number 3? In the last class we done. Just I want to summarize once. Can you go to question number 3? What is the answer? Can you try this? One question guarantee. From today's class, guarantee one question will come. From today's class, guarantee one question will come. The size of the TCP receiver window never change throughout the duration of the connection. Is the statement is true, false? It is a false, because window sizes keep on changing. Window sizes keep on changing. That is the meaning of flow control. That is the meaning of flow control. That is the meaning of flow control. What is the answer of the similar problem? Can you check? Host X has IP address and host Y has IP address. X having IP address, Y also having IP address. Both hosts are using subnet mask Z. Which of the subnet mask Z given below can be used if both the hosts are belongs to same network? I think same. You have to find mask so that both will be belongs to same network. I think you have to do this. If you go to the first one, mask is 255, it's okay. Concentrate on the last one, 224. Can you help 112, 224. Next one, 92, 224. This is the option A. First option. Second option, 252, 224. Second option is 112, 252. 92, 252. It is second option. Check properly. Third option, 112, 192. 92, 192. Third option. So we'll see 128 last. We'll see 128. If you want, I will do 128 also here. See this one here. I think 2 octets you have to check. 2 octets you have to check. 2 octets you have to check. Let's see this one. 2 112 128 0. Next one 292 128 0. Yeah, please try now. So we don't have any other option. So this is the only way. Please verify properly. 112 255 binary number. Convert into binary. 112 92. And one more thing is, you no need to convert a binary number again and again, because every option contains those only. Please give answer. Which mask contain more ones? This is also correct. This is also correct. The person who contain more ones is this one. 3 will be the answer. 3 will be the answer. Whichever contain more ones, that will be the answer. The reason is, more ones means, listen, more ones means mask is more ones. Mask more ones means less host. Mask more ones means less host. See this one in the option C. 255, 255, 255. Right? 255. See this one. 255, 255, 255. 1100. 4 zeros. Remember. 6 zeros are there. 6 zeros. 2 power 6 host is possible. Maybe -2, whatever it is. But in the option fourth option, if you see 255, 128, right? Followed by. So I think approximately 15 ones. 2 power 15 -2 hosts possible. So option C, less host. Option 3, less host. Option 4, more host. Remember, more host means you are in the middle of the path. Less host means you reached the destination. More host means you are in the middle of the path. Less host means you are very close to the destination. I just one example also. You are going in one bus. You asked the person, I want to go to this village. How many villages are left out? He said 500 villages. Oh, 500 villages are left out. Means you are so far away. You are going in the bus. You are asking one of the person, I want to go to this village. How many villages I have to cross? Only 5 villages. Oh, I am very close to the destination. So remember, both are belongs to path only. One person is close to destination. One person is on the way. So close to destination you go. I am repeating once again. Mask contain more ones means less host. Less host means you are very close to destination. Right? Perfect. So 3, 4 is the actual correct answer, but router will select 3 only, because more bits in the mask means less host. Less host means you are very close to destination. Answer is 3. Question number 3, answer is 3. Go to question number 4. What is the answer? An organization is granted the block. The administrator want to create 500 subnets. Find the number of hosts in each subnet. What is the first and last host in the second number subnet? Yeah, so what is the answer for this? So I think it is going to be classless networking. This is going to be classless networking or classless IP addressing. This is going to be classless IP addressing. So 32 minus 16, so 16. 16 bits per host, so 2 power 16 minus 2 hosts possible. So right, divide 16 means mask purpose 16 bits. So out of 32, 16 bits for mask, remaining is 16 for the host. With the 16 bits, 2 power 16 minus 2 hosts are possible. IPs are 2 power 16, right? Host IPs, you can give 2 power 16 minus 2. Okay, fine. That is okay. But what he is saying? Out of these 2 power 16 IP addresses, out of these 2 power 16 host addresses, the administrator want to create 500 subnets. So out of these 2 power 16, you want to create 500 subnets. So 2 power 9 approx. So remaining is 2 power 6. Sorry, remaining is 2 power 7. Remaining is 2 power 7. 2 power 9 subnets. Every subnet contain 2 power 7 host. Right, now check. Find the number of hosts in each subnet. Right, I think these many hosts possible. Which is going to be 2 power 7 is 128 minus 2. 126 hosts possible. 126 hosts possible. 126 hosts possible. Next one, that is fine. So how many bits for host? 7 bits for host. How many bits for subnet? 9 bits. Subnet purpose 9 bits. Host purpose 7 bits. Right? So I will try to write here itself. Right? Answer is 1 or 4. Remember, 9 bits for the subnet, 7 bits for host. 7 bits for host. Now let me check. So either this or this. 9 bits for the right subnet. Right? Out of 16 people, 9 for the subnet. So I am writing now. 9 for the subnet. 160, 46, 9 people for subnet. These 8 people dot 1 more person. 9 bits for subnet. Right? Remaining is host. Hosts are going to be 7 zeros to 7 ones. So, right, this is the 8 bits and 1 bit. Now listen, totally 9 bits. This totally 9 bits. So these 9 bits, is saying that second number subnet. See this one. Out of these 9 bits, see what I am doing. Right? So 9 bits. 8 zeros dot 0 1. Next one, 8 zeros 0 1. 8 zeros, something like this one. Lastly 1 0. This is 2. 1 0. 0 1 is the first subnet. 1 0 is the second number subnet. Right? And one more. What is asking? What is the first and last host of the second number? So it is the second number. So first host is going to be all zeros, lastly 1. Last host is going to be all ones, last 0. So this is going to be 1. This is going to be all ones. I think 7 people, 2 power 7 minus 1. 128 minus 1 is 127. right? This is 0 also gone, right? 126. This is going to be 0 1, I think 2. Right? I think see 1 0 is there in the another octet, so it is going to be 1. So I'm thinking that this is 160 46. This is 1, this is 1. 160 46 1 dot 126. These 9 people for subnet. These 9 people for subnet. These 9 people for subnet. These 7 bits per host. So 9 bits. How to write? Write subnet number 2. See the 9 bits. 8 zeros dot 0. It is a 0. 8 zeros dot 1. Next one, 7 zeros 1 dot 0. This is the second number subnet. It is the first host. It is the last host. First host is 1. Last host is 126. This value is going to be 1 dot 0, right? In this 0, first host is 1, second host is 126. So answer is 1. Answer is 1. Okay, answer is 1. Second number subnet. Second number subnet. Second number subnet. I hope everyone is fine. Second number subnet. Second number subnet. So if you observe clearly, 160 46. 160 46. 160 46. Now this is the subnet part. These are 16 people. In this, it is an octet. It is an octet. So in this, 7 people host. These 9 people subnet. So first one, all zeros, 0, all zeros, 1, 7 zeros, 1 0. Now host numbers. Host if you observe. First host, all zeros cancel, all ones cancel. Next one, all zeros followed by 1, all ones followed by zeros. This is 1, this is 126, this is 1.0. So finally 160 46 1.1, 160 46 1.126. Someone is saying 120 is not used for IP address as a loop back address starting with 127. Hello Bhaiya, starting with 127. Not host part 127, starting with 127. That is the loop back address. So this one, listen, this one you cannot use. This one you cannot use. This is going to be, this one you cannot use. This is called net ID. This one you cannot use. It is called DBA. This is for DBA, direct to broadcast address. This is for net ID. This is for net ID. This is for net ID. This is for a DBA. Remaining things you can use. Starting with 127. Array bhai. Starting with 127 is loopback. Not somewhere 127. Starting with 127. Yeah, true. So finally, question number, what is the question number? Question number 3, question number 4 over. Right? Go to the question number 5. Question number 5, check one time. Which of the following is a private address? Which of the following is a private address? So remember, class A, few people are given for private. Class B, few things are given for private. Class C, few things are given private. Right? Please go and see the notes one time. Private. Right? So it's going to be 192. Please see in the right in the notes it is there. Or Google it out, you will find out. Private IP addresses. In every class, few will be given for private IPs, which is nothing but, right, those LANs which don't have internet, how they will communicate. There is a LAN, in that LAN there are so many computers. There is a LAN, in that LAN so many computers are there, how they will communicate each other without internet. So using private IP they will communicate. Using private IP they will communicate. Right? In every class, few are allocated for private IPs. Private IP is nothing but in the LAN area without internet, how will you communicate each other? Using private IPs. That is the question number 5. Everyone know this. Go to question number 6. What is the answer? Which of the following IP cannot be used as both source IP and destination IP? Remember everyone. It is a class A. Class A. Listen. Class A. 8 bits for network. 24 bits for a host. 24 bits are host. Class A. 8 bits for network. 24 bits for host. Total host area you kept all ones. Total host area all ones, which is called DBA, direct to broadcast address. DBA will be used as destination address. DBA will be used as destination address. Host ID all ones, DBA. DBA means direct to broadcast address. This will be used as destination address. Now, see this one. Whatever it may be the class, if all ones are there, this is called LBA, limited broadcast address. Indication that within the network, send to everyone. Whichever network you are, in that network, send to everyone. That is called LBA. This is also used as a destination address. Whichever network you are, in that network, send to everyone. That is called limited broadcast address. Direct broadcast address means host parties all ones. So you have to go to that network first. This network you go first. Network 10 go first. In that network, send to everyone. That is called direct broadcast address. Now here there is no network part. See, all are ones only. That means wherever you are in that network, send to everyone. means current wherever you are in that network to everyone. That is called limited broadcast. What the direct broadcast is, going to the required network first. Because of this, go to required network first. In that network, send to every person. That is called direct broadcast. That is also destination address. And everyone, it is a loop back address. It is a loop back address. It is a loop back address. This is also used as destination address. This is also used as destination address. Answer is 3. Answer is 3. 4 is a loop back address. It will be used as a destination address. So it will be like this one. Ping. Ping, just write 127.x.y.z. Ping 127.x.y.z. Someone is saying that, but where it is given that address is classful. IP addresses can be classless and IPs may be classful, although mask not given, right? See this one. Remember carefully. See, remember carefully. In the given IP slash not there. In the given IP slash not there. In the given IP slash not there. Then it is going to be classful IP address. In the given IP slash not there, it is going to be classful IP addressing. Slash is there, that is going to be classless IP addressing. Slash will decide it is a classless or classful. Slash will decide it is a classless or classful. Yeah, go to the next one. Question number 7. Yeah, try. What is the answer of this? Jay Bhaiya, my CN is बहुत weak. Then why are you spoiling my life? Then why are you spoiling my life, Bhaiya? Bhaiya, if your CN is बहुत weak, why are you throwing stones on my life? You are throwing stones on my life. Why are you throwing on my life? Very goodly. Coming 10:35 and asking, right? My Jay Bhaiya, my CN is so weak. If both weak, why are you asking doubts? Goodly. Anyhow, come here. So, what is the answer of this? You are asking very nice questions. How can you say both weak? How can you say both weak? You are asking nice questions. Arey Shreyas, you are asking nice questions. Why are you saying both weak? Yeah, an internet service provider ISP has the following chunk of CIDR based IP addresses available with right, something like that given. The ISP want to give half of this chunk of IP addresses to organization A and quarter of organization B while retaining the remaining with itself. Which of the following is a valid allocation of addresses to A and B? Sir, you understood Hindi. Nice cover up. I no shame also. When your CN is both weak, you concentrate yourself. Don't target on me. If your CN is so weak, you concentrate on yourself. You don't concentrate on me. Do your own business. Just shut up and do your own business. Right. Now come here. Come here now. See this. See everyone. See everyone now. So mask is 20. Mask is 20. So 32. Remove 20. 16. Sorry, 12. 12. So 12 bits for host. Right, that's fine. Can you hear? Can you listen? 32 minus 20, 32 minus 20, which is going to be 12. 12 bits for host. Now what he mentioned, the ISP having 12 bits means 2 power 12 IP addresses possible. In those 2 power 12, what he done is, right? So 2 power 12 divided into 2 parts. He divided into 2 parts, 2 power 11, 2 power 11. That means, listen, that means 12 bits. So 12th bit is 0, 2 power 11, 12th bit is 1, 2 power 11, like that. So 2 power 12 divided into 2 parts, 2 power 11, 2 power 11. So what is saying, right? Half of this chunk of IP addresses are given to A and quarter to organization B. Quarter means 1 by 4. What is the meaning? I think what happened is, this one, I think again it is divided. So either this one or this one given to A. This will be A, this will be A, or this will be A. 1/2 is given to A, right? So after division is over, again division, 2 power 10, 2 power 10. One quarter is given to B. 1 quarter is given to B. So I will do this, because of lack of space I am doing 2 power 12 divided into 2 parts, 2 power 11, 2 power 11. Something is divided into further, 2 power 10, 2 power 10. So remember everyone, host purpose 12. Host purpose is 12 means mask how many? 20. Because 20 plus 12 become 32. But in this area, if you observe, host purpose 11, mask purpose 21. 21 plus 11 how much? 32. But in this level, if you observe, host purpose 10, mask purpose how many? 22. In this level, host purpose 11 bits. Host purpose 11 means 32 minus 11, 21 for mask. Next one, in this level, host purpose 10, mask is 22. Mask is 22. But I can give guarantee, listen, I can give guarantee, this may be A, this may be B. Or one more case, this may be A, this may be B. Or this may be A, this may be B. So like that, any combination can happen. Because half is given to A, quarter is given to B. Any combination can happen. Half given to A, quarter given to B. But remember, quarter means mask is 22. Half means mask is 21. If you don't divide at all, mask is 20. If you do one division, mask is 21. If you divide one more division, mask is 22. So A mask is 21, B mask is 22. Can you see the problem one time? Can you see the problem one time? Can you see the problem one time? But A and B, many combinations are there, but mask is clear. Can you clear the mask now? So what is asking? While retaining the remaining with itself, which of the following is a valid allocation of addresses to A and B? First A, next B. I think A is 21. A is 21, B is 22. 21, 22. 21, 22. See, this cannot be the answer. This cannot be the answer. A, B. A, B. First A, next B. First A mask is 21. B mask is 22. Answer is either A or B. Arey, first cry this. Humans are like this. Whatever going on, they don't. They will ask something else. Whatever is going on, they don't care. Next, right, they will ask something else. Human nature is like this. Right. Now see, answer is either B, A or B, A or B. Answer is either A or B. Why A or B? Can you see this? See this one. Can you see this one? A mask is 21. B mask should be 22. So 21, 22. A mask is 21. B mask is 22. So first A mask 21. B mask 22. A mask 21. B mask 22. Is it fine now? Yeah, fine, perfect. So answer is either A or B, right? To complete the remaining part, is it A or B? I will check now. Is it A or B? I will check. One time listen. Everyone listen one time. 245. Everyone listen one time. 245. 248. So how many bits for host purpose? 12 bits. How many bits for host purpose? 12 bits. 12 bits concentrate. 12 bits concentrate. But let me write 12 bits means third octet also required. 128 how to write? Yeah, these are the 12 bits. Careful, these are the 12 bits. Listen, so 245, 248, third octet is 128, I written. Fourth one is, right, fourth one is 0, right, see, 12 bits. These 12 bits are important to us. These 12 bits are important to us. Can you help, out of these 12, everyone listen, out of these 12, 12th bit 0, 12th bit 0, right, this entire thing is 11 bits are there, so 2 power 11. Next one, 12th bit is 1, this entire thing is 2 power 11. Twelfth bit 0, remaining is 11 people. 2 power 11, 2 power 11. 2 power 11, 2 power 11. Right, 2 power 11, 2 power 11. But you have to complete remaining part also, na? You have to complete remaining part also. Now please help me. Please help me. I am expecting answer. I am expecting answer. Please help me. Second part. This number is fixed. Second part, this number fixed. Then what is the answer? Already 128 here and one more one. Fourth bit is one. This one. This bit is one more one. 0, 1, 2, 3, 2 cube, 8. So 128 plus 8. 136. 128 plus 8, 136. 128 plus 8, you see this one, I think see, 0 bit, 0, 1, 2, 3. Fourth bit means, alright, 0 to 3, I think 8. 136. So remember, in this area, 136. In this area, it will go to 128. So remember, this may be given to A or this may be given to A. One of the thing is given to A. So according to option A, this part is given. According to option A, this part is given. This is A according to option A. Right? So according to option B, first part is given. Now be careful. According to option A, second part is given, it's okay. Right? Second part is given, okay. But in this one, if at all second part is given, in this one part is given for, right? This will be divided into two parts. This will be divided into two parts because this is given to A. According to option A, this is given to A. According to option A, 136 is given to A. Now 128 in the divide into two parts. 128 divide into two parts. See, 128. Right, according to option A, 136 is given to the A, but 128, right, in this, listen, in this 4 bits are given, fourth bit 0. Right, in this what happened is again two parts. What is the answer? Third bit 0, third bit 1. Third bit 0, 2 power 10. Third bit is 1, 2 power 10. Third bit 0, 2 power 10. Third bit 1, 2 power 10. Right? If third bit is 0, 2 power 10, what is the starting number? 128. Third bit is 1. What is the starting number? Because of third bit is 1, 0, 1, 2, I think 4. So 132. 132. So B will be either this or this. B will be either 128 or 132. So it's a 128. Right? If those people who didn't convince, it is a nice problem. If anyone is not getting this problem, can you see one time? If anyone is not getting, can you see this one time? Sir, I am not okay, sir. If anyone say I am not okay, sir. Right? I will do once again. It's the question number 7. Right? So I am doing. That's the reason I am saying I am doing. See this. Everyone listen one time. It is very simple, listen one time. So initially 12 bits for host. This one 12 bits for host. So let me write the IP address. 245, 248. 245, 248. Right? Next one if you observe, 245, 248, 128 also there. See this one, 128. 128 means this. Dot all zeros. Now everyone listen. Now everyone listen. So 4 bits for host purpose. 4 bits for host purpose. Then what he done is, right, these 2 power 12 divided into 2 parts. 2 power 12 will be divided into 2 parts. See, so 12th bit is 0, half there. 12th bit is 1, half there. So this may be A, this may be B, according to, right, if at all, if that is the case, so what is the answer? It is a 128. So 128 starting number, dot 0. According to this one, 128 plus this bit 1 also. 128 plus 8, which is going to be 136, 0. So according to option A, this is the A. Then I think, see, half is given to A. Okay, fine. According to option A, this is. Now definitely B came from this side only. See how B. See this one. Third bit is 0, half. Third bit is 1. So this 128 and here 0, right? So in this group, 128, 0. But in this group, 128 plus 4, 132. 132. So B will be either this or this. A will be either this or this. Finally, A is this. B will be either this or this. But by seeing option A, B will be 128. So B will be 1. This is B. This is not. So this is the answer for this. A is the answer. Option A is the answer. Yeah, is it fine now? You got or not? Check. See this. Here, fourth bit is 0. Fourth bit is 1. Here, third bit is 0. Third bit 1. Why you done 2 parts here? Quarter. B belongs to quarter. A belongs to half. So quarter having 2 parts. 128.0 also quarter. 132.0 also quarter. But 136.0 is half. So in the above part, in the B part, listen, in the B part if you observe, fourth bit also, third bit also fixed. See, fourth bit fixed. These are all people, fourth bit fixed. For these people, right? So it is the fourth bit. This is the third bit. Half. Fourth bit, half. Someone is asking, can we have first quarter, then half in the second quarter? You can arrange whatever it is according to options. See, you can take B purpose, you can take this also. Then B should be 132.0. B can be this also, 132.0. And one more thing is, he can make here quarter. This may be A also. This is A. This may be B. Then A will be 128.0. Then B will be 136.0. Or either this part also. This part also. Right? So you have totally 2 power 12. Divide into 2 parts. Right? Divide into 2 parts. 12th bit is 0. 12th bit is 1. So it is having 2 power 11. It is having 2 power 11. So this is A, assume. So here B. Again 11th bit. 11th bit 0. 11th bit 1. 2 power 10. 2 power 10. So this is B. It is starting with 136. This is starting with 128. Yeah, can we go next? You do CN daily, sir. Who knows? God knows. You do CN daily, sir. Who knows, yeah? God knows. Yeah, perfect. Go to next. Yeah, so what is the answer of this? Can you see this? Try this. Same problem, similar problem. Can you do one time? So what is the answer? Doing AND operation. Same problem. I think those IPs and these IPs are different. Same or different? Yeah, fine, that's okay. Perfect then. B. Question number 8 is B. Go to question number 9. Question number 9, what is the answer? Try. The router connecting a company's network to the internet applies to the mask to the destination addresses of incoming packet. Okay, if one of the incoming packets has a destination address is this, then find the network ID, subnet bits and the host ID bits of incoming packets respectively. So first of all find out net ID. First of all find out net ID 255 192 145 33 7 220. Do end operation, you will get the clarity. So this is 145, this is 33, this is 7 because 1 and anything is anything. See this one, 1 and anything 1 and anything 1 and anything. So until now it's okay, but it is not 192, right? Few are ones, few are zeros, right? Can you convert into binary format? 192 1100 4 zeros. 220 how? 128 64 32. 220 how? 32 and 8. 8 plus 4 12, 12 plus 2 14. Check properly. 220 how? 12 plus 2 14. I think 16. I think it's going to be 11 11 00 00. Am I right? No? Yes. Let me check here. 128 30 64 192 192 plus 32. So it's going to be, someone is mentioned 16 plus 8 plus 4. Okay, so let me change them. So someone is written already 11 0 11 0 11 11 0 11 1 0 0. Is it okay? Double 1 0 double 1 so it is a triple 1 maybe. Yeah, do end operation properly. So what is the answer you are getting? But anyhow it is useless, right? It is unnecessary also, right? Even though it is right, so it is unnecessary. Anyhow, double 1 will come followed by all zeros. Anyhow, even though we done wrong, no problem, because this only will match. This only will match, remaining all will not match. So this is, I think it is going to be 192. It is going to be 192. Remember, if you do end operation, mask and IP, if you do end operation, you will get net ID. What is asking? Network ID. Network ID. Find the network ID 192. Even though we done right, even though I done wrong here, there is no problem because end operation we are doing. So net ID is 192. Anyone having any doubt till now? Anyone having any doubt till now? Just to do end operation. Yeah, so that's fine. Network ID, subnet ID same. Network ID, subnet ID same. Don't worry. So network ID is 192. Right? So this is the network ID. If anyone asks you network ID, so this is the actual answer. 145.33.192.0. This is the network ID. This is the network ID. Yeah, now see the next one. Yeah, sorry for this. 7.192. Yeah, you are correct. This is the network ID. I am repeating, I think I written something wrong. I am once again rewriting. Once again I am rewriting. Already available, right? While writing I written wrong. 145.33.7.192. Last start date is 192. Yeah, this is the answer. Is it okay? Last start date is 192, before is 7, before is 33, before is 145. Now listen everyone listen. There is no slash, so it is going to be class full, right? There is no slash, so it is going to be class full IP addressing. There is no slash, it is going to be class full IP addressing. And one more, by seeing this 145, it is a class B. By seeing that 145, it is a class B. It is a class B. If anyone say how class B's are, you know, starting with 0, class A. Starting with 10, class B. Starting with 110, class C. Starting with 1110, class D. 4 ones, right? Class E. So this one, if you observe, 128. This one, if you observe, 128 plus 64. What is the answer? 192. 192. 128 plus 64. 192. So until 191. Fine. So 0 to 127. So this one everyone know this. Just remember this pattern. Now listen, it is a class B. According to class B, everyone listen. According to class B, network part 16, host part 16. According to class B, network part 16, host part 16. Network part 16, host part 16. Right? I think now you got to know. Network part 16, host part 16 means, if you observe clearly, network part 16, host part 16. Right? So these two are okay. These two are okay. These two are okay. In the mask area, these two are okay. In the mask area, how it became 255. In the mask area, how it became 255, how it became 192. In the mask area, according to class B, 16 bits for network, 16 bits for host. But if you observe in the mask area, more than 16 people became, right? Network part. So then what is the meaning? I think here 8 bits, here 2 bits, 10 bits became, actually they are part of the host. Actually they are part of the host, but subnetting is done. I think 10 bits for subnet. In the mask everyone know, network part plus subnet part is ones, host part is zeros. Are you getting? Network part and subnet part is ones, host part is zeros. Actually class B only first 16 only ones. How remaining also ones came? Oh, it's the subnet part. Subnetting means borrowing bits from host area. I think 10 bits he borrowed. 10 bits he borrowed. Am I right or not? He borrowed 10 bits. He borrowed 10 bits. So if you really okay, just I want answer from you. Please help me. What? How many bits for host? I want answer from you. How many bits for host? Please help me. So 10 bits for subnet means out of 16, 10 bits for subnet. I think what is the answer? 6 bits for host. Right, 6 bit for host. Now listen, 145 33, let me write here, 145 33 7 220, 7 220. I think this one, 7 220. Yeah, 220. Now listen. So 145 33 7 220. Let me write the binary format necessary, people. 145 33. This 7 can be written as, everyone listen, this 7 can be written as 111. 220 can be written as 11 0. See, let me write now, 11 0 111. Double 0. Now listen now. So these people are belongs to, right, subnet. So subnet number is going to be 7 dot. This is going to be host part. What is the host? Right, subnet number, right? This IP belongs to subnet number 7.192. It is a subnet number. Only subnet bits only take. Are you getting? So in between there is a dot, right? In between there is a dot, right? Am I right or not? In between there is a dot. Totally 10 bits. 8 plus 2. 8 plus 2. 8 plus 2. 7.192. So this is the host part. Can you say what is the host number? Can you say host number? 6 bits for host. Host number 0, 1, 2, 3, 4. 16 plus 8 plus 4. 28. We done so many problems in the classroom. Like this. It is a class B network. 16 for network, 16 for host. But by seeing mask I got to know mask contain 16 plus 10 bits once. mask contain 16 plus 10 bits once. So this 10 is for subnet. Class B saying that 16 plus 16. Mask saying 16 plus 10 once. Oh, this 10 belongs to subnet. So those 10 people you go. Exactly 10 people in the given IP. That is going to be network, that is going to be subnet number. Fine. Fine. Is it okay? So given IP belongs to subnet number 7.192. Given IP belongs to subnet number 7.192. Given IP host number is 28. Given IP host number is 28. Subnet number is 7.192. Network part is 145.33. Network part is 145.33. So if you do network ID and mask end operation, network ID, sorry, if you do IP address and mask end operation, you will get net ID. That's what we done. See this one. So mask and IP do end operation, you will get net ID. This is the net ID. But class B saying 16. But why these many ones in the mask? Oh, mask means network ID plus subnet. Network part and subnet part all ones. But network part 16 only. But how here 26 bits are ones? How 26 bits became 1? Because network is 16 only. How 26 bits became ones? Oh, right? 10 bits for subnet. So corresponding 10 bits you take after network, corresponding 10 bits you take in the given IP, then you will get the subnet ID and the host part and so on. So I think everyone is comfortable here. So right, let's go to problem number 10. This is problem number 9. I think everyone is comfortable. Go to problem number 10. It is very simple. Can you go ahead? Two computers C1 and C2 are configured as follows. It is a simple problem, do it. Compulsory one question will come. That is the reason these many problems are there. Yeah, if anyone is not done, please do. Please like and subscribe. Please like and subscribe. Two computers C1 and C2 are configured as follows. C1 having IP address and a mask. C2 having IP address and mask. Which of the following? I think this kind of problem already we done. But this will come guarantee in the exam. This one will come guarantee in the exam. C1 having IP address also, mask also. C2 having IP address also, mask also. So please do once. C1, I think if you see the mask, I think 255s are 2 only. So 2 octets you have to take care. 2 octets you have to take care. What is asking? C1, C2. Both assume they are in the same network. I think AND operation. C1 first mask, C2 first mask. So let's see. C1 first mask. What is C1? 2.53. Mask is 128.0. Right? And C2, let's see the C2. 75.201, 128.0. With the C1 mask, I done C1, C2. With the C2 mask, I will do C1, C2. Do AND operation one time. I think it is 0.0. It is also 0.0. I think 2 octets. So I think these two are same, these two are different. C1 same, C2 different, I think. Check properly if I done anywhere wrong. Lastly 64, remaining all zeros. Yes, perfect. C1 and C2 both assume they are on the same network. C2 assumes C1 on the same network, but C1 assumes C2 is on the different network. C1 assumes C2 on the same network, but C2 assumes C1 on the different one. Don't you think it is C? C1 same, C2 different. Do AND operation, nothing there, nothing, practice. Do AND operation. Right. Question is equal to question next. Go to is equal to go to hell. Arey Rohit, go to is equal to go to hell. Why C2 different? See na? See? Right. So 10 problems done. Go to the 11th problem. The protocol data for the application layer in the internet stack is The protocol data for the application layer in the internet stack is. Means you want to say that in the application layer data is called what? Message. In the application layer data is called message. Right? So datagram UDP, segment TCP, frame data link layer, right? Packet network layer, bits physical layer, frame is data link layer, packet is network layer, bits is physical layer, message is application layer. Yeah, everyone know, but it is given in one of your previous paper. Yeah, can you go to next one? Which of the following transport layer protocol is used to support electronic mail? Transport layer is not asking application layer. Remember, it is not asking application layer, it is asking transport layer. Which of the following transport layer protocol? Transport layer protocol, right? Transport layer having two protocol, TCP or UDP. Which of the following transport layer protocol is used to support electronic mail? So remember everyone, right? So mail TCP, because you don't want half mail. You don't want half mail. Mail should be proper order. Mail should be properly ordered. Half mail came, half mail is not came. It is not good, because in the UDP you may lose packets. UDP is not reliable. TCP is reliable. If you use the UDP, mail is not reliable. You will get a half mail. You may not get a half mail. TCP reliable. So mail also reliable. If you want reliable mail, go to TCP. So answer is C. Because mail is reliable. Mail is reliable. Reliable means TCP. Right? Fine. See, people will select SMTP. People select SMTP, right? But is not asking application layer. Which of the following protocol used to support electronic mail in application layer? Then SMTP. Application layer SMTP, but transport layer mail. Yeah, you don't want half mail. If you go for UDP, half mail you may get, because it is not reliable. Something maybe you will lose, but TCP you don't lose anything. Sorry, SMTP is not a protocol, it is a protocol of application layer. SMTP is the one of the application. SMTP is the application layer protocol. It is a protocol because SMTP, P is finally protocol only. Simple mail transfer protocol. It is a protocol but application layer. Yeah, maybe. Fine, now let's go to next. So 12 over. Go to the 13. In the IPv4 addressing format, the number of networks allowed under class C is, listen everyone now. Class A, class B, class C. Listen, in the class A, 8 bits for network. Class B, 16 for network. Class C, 24 for network. Here 24 for host. Here 16 for host. Here 8 for host. Listen, this is the place where many people will do mistake. That is the reason I given this problem. Many people will do mistake. Many people. He is saying class C. Listen, everyone now. He is saying class C. Everyone listen. He is saying class C. Remember, 8 bits for network, but 1 bit fixed. Here 16 bits for network, 2 bits fixed. Here 3 right. Here 24 bits for network, but 3 bits are fixed. 3 bits fixed. So remaining is 21. So 2 power 21. 2 power 21. 3 bits are fixed. 1 1 0. Class B 2 bits are fixed because 1 0 prefix. Every class having some prefix. Every class having some prefix. Every class having some prefix. Class A starting with 0. Class B starting with 1 0. Class C starting with 110. Or out of 24, 110 means 3 bits are over. Remaining is 21. 2 power 21. So that is the reason I given this. It troubled me also. I thought it will trouble you also. That is the reason I given this. Go to question number 14. Try this also. Suppose computers A, B have IP addresses 2 and they both use the same net mask n. Which of the values of n given below should not be used if A and B should belongs to the same network? In the first one, I think last one is 0. I think they both belongs to. In the second one, last one is 128. It's a 1, right? 128. It's a 113. So 0. 91, 0. I think second one also perfect. Third one, 192. That is going to be 113. So 128 is common. So this one is 91. I think 64 common. I think D. I think they are very easy also. I think D, check. Do end operation. Yeah, fine. He's saying which one is not to say A and B is belongs to same. I think it is a normal. So 14 is going to be D. Go to 15. Packets of the same session may be routed through different paths. It is the source, it is the destination. Right, it is the source at the destination. Right, so many packets are coming. Packet 1, packet 2, packet 3, packet 4. So many packets. So many packets. So many different paths are there. Different paths are there. There may be routers in between. Different paths are there. Can you help me? Can you help me? Everyone. It is a very interesting one. It is a very interesting one. It is a very interesting one. Please listen, everyone. It is a very interesting one. Please listen, everyone. Yes, having 4 packets. Yes, having 4 packets. those 4 packets will go different path or same path? This is the one which will trap. It is a trap. It is a trap. Can you help now? Can you help now? These all packets will go different paths or same path? These all will go same path or different path? TCP is a connection oriented. UDP is a connectionless. TCP is a connection oriented, means circuit switching. TCP follows circuit switching. UDP follows packet switching. TCP is a connection oriented. UDP is a connectionless protocol. TCP is reliable. UDP is not reliable. And one more. In the TCP, all packets will come in the proper order. In the UDP, no order. UDP don't have sequence number. TCP having sequence number. UDP don't have flow control. UDP don't have congestion control. UDP goal is somehow going. UDP goal is somehow going. UDP goal is fast. Remaining all are drawbacks only. So, in TCP follows circuit switching. UDP follows packet switching. In the TCP, no packet you lose. In the UDP, you may lose packet. So, that is the reason not reliable UDP, TCP reliable. But remember, everyone bother about fast also. Comparing TCP, UDP faster, okay, but everyone bother about fast, right? Remember everyone. If this path is free, few will go by this. If this is also free, few may also will go this. So everyone remember, some people are misunderstanding. TCP is a circuit switching. Means connection oriented. Connection oriented doesn't mean that, right, all will go in the same path. All will go in the same path. If network is, right, traffic is less in the upper may all go. If traffic is more in all, few packets will be upper, few packets will be below, few packets will be middle. So remember everyone, TCP, UDP both. TCP, UDP both. Packets of same session may be routed through different paths, of course. Right? It is decided by, right, routing algorithm. Routing algorithms will be decided. Routing algorithm will be decided. Routing algorithms are decided. Whichever better routing algorithm will follow. Appearance, it looks like TCP is a circuit switching, connection oriented. People thinking that connection oriented means all packets go in the same path. No, it's a connection oriented, means reliable, and sequence number also there, so out of order will not come. And right, lastly combine also there. Secure. You don't lose anything, so reliable. This is a very, very important one. If I don't say this, you may think that TCP, all packets will go same. If all will go same, it is a worst idea. If all will go on the same path, it is a worst idea. Okay? Remember, TCP is a connection oriented. Circuit switching means, see, not physically, logically. It look like that, but physically not happening like that. TCP connection oriented. TCP is a circuit switching. It look like connection oriented. Connection is there. So not physically, logically. Yeah, that's what. See, TCP, whatever you know, same. Circuit switching, connection oriented, everything fine. The only difference is it is not physically, logically. Logically. Fine? Yeah. I think in this class, I covered 15 problems. In the next class, we will see remaining. Okay? In the next class, we will see remaining. 15 covered.